Okay, we're going to go over the second section now within 5.3. This is where we're going to use factoring to solve, and kind of the two main concepts, and we really did this a lot when we verified identities. One was factoring out a GCF, and the other one was taking a trig expression and factoring it into two binomials. Okay, we look at number one. Well, we know we couldn't get sine by itself for number one, because not only do you have sine of x, but you have sine squared. So we're going to pull, this is one where we pull out a sine, right? Each of these have a sine, so we pull out sine of x, that's our GCF. Then on the inside we get 2 sine of x minus 1 equals 0. And then once you have it factored out, you take each factor and set them equal to 0. So we have sine of x equal to 0. This one right there, if you take 2 sine of x minus 1 and set it equal to 0, well then you would isolate the sine of x. You would add 1 and then divide by 2, so this sine of x would equal 1/2. And then you solve for each just like we did previously. So let's see here, sine of x equals 0. So you're asking yourself, where are the y values 0 on the unit circle? And that would be at 0 and pi. Okay, the other thing it says is find all solutions, so we're just going to say plus 2 pi k. Okay, we add that at the end. So those are some of the answers. And then if we have sine of x equals 1/2, well the y value is 1/2 at pi over 6. And then sine is also positive in the second quadrant, which is 5 pi over 6. And then we'll add 2 pi k to it. So these are your answers there. Okay, so number one is where you factored out a GCF. Now number two, if you look at this right here, you cannot take out a cosine. The reason is because of this 2. There's no cosine with it, but it looks like a quadratic trinomial. So this is where you could factor these into two binomials. Once you notice that that's what you have to do, it's very easy. If you don't get it right, a lot of times the students don't recognize it right away. So I'm going to factor these into two binomials. Now since it's cosine squared of x, since it's cosine squared of x, the first term is going to be cosine of x in each binomial. And since this is a plus and this is a minus, this is telling me I'm going to have two minuses here. And then it's real easy. Your only factors of 2 are 1 and 2, so you could put the 1 and 2 wherever you want. And if you FOIL that out, the cosine of x minus 1 times the quantity of cosine of x minus 2, you would get this trinomial that you started with. Then you do the same thing we did for number 1. Take each factor, set it equal to 0. So for this first one, you're going to have cosine of x has to equal 1. For the second one, you'd have cosine of x would have to equal 2. Okay, and then this right here, I'll move this down here. If cosine of x equals 1, remember cosine is the x value in the unit circle. You're asking yourself, what are the x values where x equals 1 in the unit circle? And it would be right at 0. You could say 0 or 2 pi. So I'll put 0 plus 2 pi k. That's the same thing as also just putting 2 pi k. And then for this, cosine of x equals 2, you're not going to get an answer for it because the x and the y values can never be more than 1 in the unit circle. So we'll say like empty set, there's no solution. So this is it. That's your answer. You could say 0 plus 2 pi k, or that's the same as just saying 2 pi k. Okay, let's do one more on the next page. Okay, the next page, we're just going to do number 5. 3 and 4, just like number 2, you would factor those into two binomials. So let's make this a little bigger here, and let's just focus on number 5. Alright, whoops. There we go. Alright, now number 5, the first thing we notice right away, it's not set equal to 0. So I want to move this 2 cotangent of x over to the left side. Okay, you can only factor if you have the equation set equal to 0. So we're going to have this cotangent of x, cosine squared of x. And then the 2 cotangent of x, if I move it over to the left side, I subtract it. So it's minus 2 cotangent of x equals 0. And then it's just like number 1. You could factor out a cotangent of x because that's the common trig function. So I'll take out cotangent of x. On the inside, we're going to get cosine squared of x minus 2 equals 0. Then same thing, once I have it factored, I take each of the factors, set them equal to 0. So I have cotangent of x equals 0. Here, now we have something squared, so cosine squared of x would have to equal positive 2. And let's solve for each. So cotangent of x, if that equals 0, cotangent in terms of x and y in the unit circle is x over y. So if that has to equal 0, then that's telling us the top, x has to equal 0. Because if y was 0, it would be undefined, it wouldn't be 0. So all the x values that are 0 in the unit circle, let's see, those would be pi over 2 and 3 pi over 2. So put pi over 2, 3 pi over 2, and then since we're solving for all solutions, we'll put plus 2 pi k. So that's the answer for that factor. For this one right here, we would take the square root, and we would have cosine of x equals plus or minus root 2. Now square root of 2, that's more than 1. That would be like 1.41. So that's not in the range of cosine or sine. So this is one where you don't get any answers for it. So it turns out these are the only answers. Alright, so for this video, you really just went over two factoring techniques. Either pulling out the GCF, or if it looks like a quadratic trinomial, like number 2, 3, and 4, you factor those into two binomials.